Everybody, welcome to this talk, Event Streaming in the Cloud Native World with Apache Pulsar. Thanks again, Alex, for introducing this very warm welcome. But before I go a little further, if you like, to kind of like follow along and read the slide deck, here's the QR code and also the bit.ly link. So just leave here for 10 seconds or so for you to take a quick snapshot or kind of copy down the bit.ly link. And then, but even if you miss, don't worry about it because I've shared this information with the Bellsoft group as well. So, okay, I'm gonna move on now. Very quickly, right? Who am I? I'm a senior developer advocate at DataStax, and Alex already described them, and so I won't go through that. But previously, I was also a developer advocate at IBM on doing Java open source type of advocacy, and then also into the open source side of WebSphere, that end too. And then I'm based in Chicago, and I'm also a Java champion and president, executive board member of the Chicago Java Users Group. I'm just a very active community builder. Before this, I was a development engineer and also done various things, including technical architecture too, at various companies too, primarily in the Chicago area. So that's about me. And so here I am. And let me kind of really quickly go through, as I know we don't have too much time, so this will be kind of a quick one, but to get you all excited about event streaming and using Apache Pulsar, and also to our company DataStax and how we support it too. And so this is a quick agenda going through. It's just some introduction to making sure we are all on the same page, right? About event streaming, all of these computing events, it can be very confusing to somebody new to this. Even let's say you've been doing computer work for a long time, this may be new. So just give me a few minutes, introduce all of these terms to you. And then also then after this, we'll kind of talk about why event streaming, right? How does it improve your systems? And then I'll introduce you to Apache Pulsar, and it's something more, tell you something more about that, and how is it different? Why do you want to consider it? And I'll highlight a couple of developer features as well. And then also introduce to you then the DataStax managed cloud platform makes your development work much easier to work with Pulsar too. And then I may have a quick demo if I have time. If not, then I also can tell you how you can watch some of my demo live too. All right, so let me start, right? The many facets of computing events. Let me kind of really quick through kind of like steps. Let's start small, right? What is an event, right? Generically speaking. So it can be, basically, I look up the dictionary, merriam-webster.com. Basically, it says something that just happens. It's an occurrence, right? So if I look further, right, looking into we are all developers, I am guessing, right, or technical folks we have a more scientific mind. So the theory of relativity comes into play because an event is really represented, right, as a point in space and time. So it's basically the three coordinates of place, X, Y, Z, and with the very interesting time aspect to it. Not only that, right, an event happens, it's immutable. Once it happens, you can't wipe it away. Think of a real world too, right? We have a birth of a baby. It happens, you can't wipe it, go back in time. A musical event, it happens, can't go back in time, and you get the idea. And then just really quickly too, right? In the world of event computing, there are just so many terms these days and can be rather confusing to somebody new. But the idea is that it's basically it works with data. That's the kind of the crux of this whole thing. Essentially too, data can be data in storage. And as Alex pointed out, right? And Cassandra, we've been doing data at rest, right? The storage side, Cassandra, which is great, right? Doing like especially in cloud kind of environment, cluster environment, and very high availability, big data, huge volumes. But now too, there's a need too for doing data in motion, right? And it's not just at rest, and it's also data in motion and data in use, which actually we'll just talk about data in motion today, right? So data is moving through streams and all of these things. And essentially, too, you look at all these terms, right? Event streaming is what we're going to talk about. And essentially, there's also the messaging aspect, a tightly kind of couple, or not, I shouldn't say couple, I shouldn't use that word, but more like messaging, streaming have tight relationship too. And then, of course, there's the processing part as well. And then event-driven architecture is also, you hear about it every day. Event sourcing is another way of how you capture all of the events, being able to go back in time and replay, for example. And then event storming is a bit more dealing with data-driven domain or domain-driven design, right? It's more on the requirement type of aspect. Okay, so these are kind of basic terms. And then we also have reactive systems that they essentially make heavily use of event kind of mechanism to do its work to kind of essentially make systems more responsive, more like real time, and also resiliency, scalability, all of these things too. And then there's also microservices that we are all hearing so much these days. And because of this highly decoupled nature, event kind of way of doing things is the way to go, as well as serverless type of applications too. So in other words, we're in a world in which, things are changing really fast. We want kind of very responsive systems and in real time too, not only process a lot of data, but also in kind of in real time. So let's kind of go back a little bit then. Talk through each one of them quickly. Event streaming processing. So basically it's the practice of taking action, right? We talk about events are data points in space and time. So any system admits data. Once it's there, it's there. But basically too, your data will keep changing state too, right? There are all the state changes. If you kind of look into plotting your graph, right, of traveling through space and time, your data point, it's kind of like a graph, right, going through time. Now, it's simple enough to do one event. You can kind of happens and it goes through space and time, but we live in a world that's kind of full of many things that can happen anytime. It's unpredictable in some ways, right? Unbounded, so to speak. And so basically, event is each data point in the system. Stream is an ongoing delivery of those events. And we live in a complex world, so there are many, data points flowing through space and time, and these are essentially streaming data or data streams. And then there's also this term called complex event processing. Basically, it's a set of techniques, right, that capture, and not only capture all of this data, but you analyze the streams of data as they arrive, in real time. And the point is that this will enable your systems and applications to be responsive, right? It's responding to events and trends and patterns in the data as they happen. And then, of course, too, there's also the event-driven and versus message-driven type of messaging, too. So event-driven is essentially deals with sender admitting the messages. And basically, I don't worry about the address of, who I'm sending to. Basically, it's the subscribers. I'm interested in the messages, I'll subscribe to a topic. And then basically, when the messages arrive at the topic, you'll receive it too. So that's more event-driven kind of way of describing messaging. And then there's also message-driven, in which the sender and receiver, you have to know each other. In other words, your address has to be known too. So that's kind of like the two differences, but they are highly decoupled way of passing data from one point to the other. Now, then let's take a look, right? Event is not the new thing, right? If you kind of look at event approach, is basically an event happens and then you immediately process it, right? So the more like traditional way is we're doing batch processing. So it has its place in the computing world too. You gather all the data that's there, and when you're ready, you batch them all up. So you send it in one kind of batch, right? That's why it's called batch processing. So it has its specific use too, in our computing world. But basically, as you can see, event is you be able to process it right away. So that's the advantage, the real-time aspect of it. So now let's kind of take a look at the patterns again. We talk about the event-driven kind of way. It's essentially kind of streaming too, which is pubs up, right? That's very much what's talked about is an architectural pattern. So basically, your client will send the data to the topic. Your publishing client send to the topic. Broker will be the one that owns the topic, and then will be the one that delivers to who. So that will be the client that are interested in the data. They will have to subscribe to the topic. And when the messages arrives at the topic, the broker will take care of delivering it accordingly to the subscriber. And then there's also another way we're talking about message queuing, which is also a form of asynchronous service-to-service communication. It's a bit more like, the sender sending data to some queues. So once, it gets into the queue, basically receiver too, of course, if you're interested, then you basically pick up messages from the queue. But once the messages get picked up, then it will be gone from the queue. Okay, so now event streaming is a step beyond event messaging, right? What is driving the change is basically we need, real-time data to basically enhance your customer experiences, right? And basically help you to create a competitive advantage too, if you can deliver your end results to your users faster. And also too, in today's world, we're talking a lot too about artificial intelligence, machine learning type of applications, building data pipelines. So that's where also event streaming can come into play. And then another aspect of why you want event streaming is that the scalability aspect is really good. Think of the pops up pattern, right? You can enable your system to ingest data in high volumes, during peak times, and also shrink back too. So that it's very dynamic kind of way of being able to take data in and, at the right time and not have things being backed up. There usually back pressure built into in this kind of mechanism too. Okay, so this just really quickly kind of talk about again, you have event streaming, you then allow your, the events, to allow your system to watch for events. When it happens, then you can do something to it right away. No need to wait for it. And then you only subscribe to topics that are of interest to you. So you receive messages that are of interest to you, very efficient, right? And helps you to make decisions on data in real time, not after the event. And, again, ingest high frequency of messages, but with very low latency. And then really quick too, to kind of compare, right? Is streaming, event streaming, modern day event streaming versus the more traditional way. So if you look kind of beneath, right, the not streaming time, if you kind of look at that, right, it's basically we can kind of use one example of the extract, transform, load process, ETL process. It has its place in the computing world. It processes huge amounts of data, also quite efficiently once you get the data in. But to get it in, it may be a little bit kind of taking a bit of time, because then you persist the data to disk, and so that kind of involves I/O, and then you select the data back and then read them and process them, so on and so forth. So it's a bit kind of takes longer time, especially when you're dealing with huge volumes of data. However, if you kind of look into modern day streaming, we're talking about ingesting data as they come, and then you process it in memory. And then once you process it, you transform your data, you write the output to a sink, and so on and so forth. It allows you to build out like data pipelines. It's the modern day event streaming can allow you to do that. So now let's take a look at Apache Pulsar. Pulsar is basically an open source software, right? Apache Foundation created by Yahoo, not Yahoo created Apache, but Yahoo actually started working with, I believe, with Kafka. And then even though Kafka is a good, distributed messaging broker too, and everything, it started off like at LinkedIn. But then Yahoo realized that, well, the world's changing. We're working more with cloud kind of infrastructure. So they started saying that, well, Kafka is kind of a bit limiting if you get to scalability aspect. And a lot of times if you need to, kind of increase your number of nodes in your system, you need to recalculate how do you rebalance all of your topics, your brokers, all of these things. So basically Yahoo said, well, let's kind of start our own. So they started writing Pulsar. And in 2016, they donated it, open source it to Apache, and it quickly became a top level project. The reason is that it is very cloud native, right? By design, it is a cloud native type of system, recognizes the needs in the cloud environment. So by nature, it's already cluster based. Also, too, it supports multi-tenancy. As you know, right, multi-tenancy is really about you can have one physical cluster, but logically, you're separating out all of these, different types of messages. So natively, it's already built into Pulsar, so it makes it much easier to work with. Otherwise, you have to deal with, okay, what messages are coming? I have to do more work of identifying, isolating different usages, right? Kind of like that. So the multi-tenancy aspect, and plus two, and in terms of client, you're writing your producer code or subscriber code. And so in terms of the APIs, we have many bindings too, and primarily Java, but it also supports Python and Go and .NET, C# client, C++, you name it. There's also like open source community contributions such as Scala, Haskell, Rust as well, and others too. Now, one thing about Pulsar is that it separates out the compute and the storage. As you know, these are event streaming type of platform, processing huge amounts of data. And so what to do, right? It becomes a laundry basket of messages too. You need to kind of be able to have a way of looking back up on your messages and store them, something like that, right? So, okay, so Pulsar said, well, it's like a laundry basket. I'm doing things and a lot of, I'm already busy enough dealing with my messages. Messages, I have to kind of worry about message retry if it doesn't work, messages timeout, all of these kind of things, message deduplication, retry, all of these things. So Pulsar said, well, I'm gonna have another thing help me with the storage. And so they picked Apache Bookkeeper. So Bookkeeper is a project too. It's very efficient, has its own ledger system. Now, as the name suggests, right, Bookkeeper is essentially the bookkeeper. It's like accounting keeper. So I manage all of these records, so to speak, right? Records, use the word records. It's basically the recording of your messages, basically take them and store them accordingly in segments too. So very efficient. So basically the Pulsar broker will work with the bookkeeper to handle all of these messages, right, in the kind of backlog and, in the back storage. Okay, so another thing too about Pulsar is that because it's event messaging system, you want to guarantee these are async way of delivering messages. So there's also already built-in Pulsar that has guaranteed message delivery built into it too. And now, okay, so now let's move on. Pulsar also has what is called Pulsar functions. It's itself a serverless type of framework. So in other words, right, you're writing your data or you're publishing your data and it travels through the pipeline and you want to do some way of transforming your data. For example, filtering, simple kind of filtering or complex filtering, or looking up some database for your data and do further processing and then send it downstream. So Pulsar has this Pulsar functions framework and it's also very energy efficient too. So think of it that way, lightweight, right? And write once, deploy it, and Pulsar infrastructure will take care of things for you in the cloud. So that's essentially what it is. And then another feature is basically called tiered storage offloads. As you know, right, all of the storages, the topics and messages are managed in Bookkeeper. So sometimes it can become, kind of too much too, and then you get charged, right? And you're doing things in the cloud. So basically, Pulsar said, well, you can offload it to something less expensive, such as S3 buckets, Google Cloud Storage, all of these things, file systems. You can kind of configure Pulsar to do that for you. So this is also a very nice feature of Pulsar that it has to offload all of these less active type of messages. So you'll be saving money, right? Talking about software sustainability is really good. So again, what is Pulsar? Really quickly showing to you the three graphs is showing you that the number of GitHub stars is rising, number of contributors, active contributors, everything is rising too because of the, the nature of this system is being so cloud native kind of aware. So it's really event streaming platform kind of targeted for the new, time that we live in. Okay, and who else is using Pulsar? So these are the, just a small handful, and Yahoo is still using it heavily, and all of these other, kind of big companies too. And how is Pulsar different? Okay, that's the kind of a $1 million question I get asked everywhere. But let's kind of first take a look, right? Pulsar, again, summarizing it, you write code, produce a code, a consumer code. These, again, you can write it in Java, in C#, all of these things that I talked about earlier. And then basically, too, you have a serverless, a stateless JVM broker running there too, and it can be partitioned right on your cloud environment, all of these things, and it handles all of the incoming messages, message dispatching, communicates with the Pulsar configuration store, all of these things, and communicates with the bookkeeper. Then there's also Bookkeeper. Again, it's kind of helps you with persisting messages. It's kind of a message store, and then also too, it uses Zookeeper to help with kind of looking at managing your cluster, your metadata, all of these things. But just want to kind of quickly point out, basically the company that the Yahoo engineers started called Stream Native, they are already looking into developing, they actually have developed some beta version of Oxia, which will kind of, is a scalable metadata kind of system that kind of would be replacing Zookeeper. And now let's kind of take a quick look. Architecture advantage of Pulsar. As you can see, I won't go into all the details, but as you can see too, basically compute storage separation, and it's a very segment-oriented log messaging management system as such, right? It's kind of the bookkeeper way of segmenting off all of these log messages in a very efficient way. But it's just a small comparison. Apache Kafka doesn't have this separation, so it manages things in a very partition kind of centric way. Okay, so this too is, you may be asking, right, Apache Pulsar, what does it solve the problem? You already have invested in Kafka, JMS, or RabbitMQ, for example. Basically, you think of Pulsar like a central hub bolt-on, right? You can continue using your existing system that have been running so well. You don't want to throw away all your money. Basically, too, even at DataStax, we have actually a free tier API layer called Starlight and it can talk protocol level into Kafka. We have Starlight for Kafka, or Starlight for JMS, or Starlight for RabbitMQ as well. So these will help you too if you're looking into migration or kind of like looking into, kind of growing your systems and modernizing it. You can still keep some of the things that you have already invested in, more traditional systems. So it's essentially a unified solution for PubSub, for streaming, for queuing, and also message mediation and enrichment through the use of the Pulsar functions. Again, this is, describing Apache Pulsar. It's really a unifying platform. It's a good friend of everybody. It also has this feature called geo-replication, which actually helps if you have huge data center, you need to do replication. It's already natively kind of built in. You can configure it. It does message selection, in terms of replication. And you can do active, passive type of mode too, for example. And then what else did I forget? I think that's about it. And if you have system on the right-hand side, you have very typical company. You have different production systems using different kinds of software, DBMS, cloud messaging. It's usually kind of siloed, right? So think of Pulsar coming in as a unifying platform. So that's kind of like the thing that Pulsar can promise you to do. So a couple of highlighting a couple of kind of developer features. Data pipeline illustrated. Think of the water like data flowing through the pipeline, and then it goes through Pulsar function for the transformation, very efficient, right? Lightweight. And then it comes out on the other end to your sink. And that's the idea. So we use function in there to do the transformation. Pulsar functions, again, is basically allows for complex streaming processing in a very lightweight kind of manner, very green. Just think of sustainability type of coding, use less memory too. It kind of takes up, kind of like inspired by AWS Lambdas and Google Function, that type. But currently, it supports only Java, Python, and Go, but there are efforts to developing support in other languages as well. And then there's also Pulsar schema. So as we know, right, we're dealing with event messaging. You have to go through the wire, serializing. So if you don't do that, you have to essentially convert your messages into byte arrays. But the thing is, you can use Pulsar schema that basically it also helps you to kind of keep track of your version changes of your schema too. And then all of the types that are supported, including like primitive types, key value pair, Avro, JSON, protobuf too. And then there's also this feature called Pulsar I/O, which is like it helps you to build your data pipeline, and essentially too the number of pre-configured connectors, either they are source or sink, it's about like almost 100 different types of pre-configured kind of connectors. But if you have something that you want to connect to and it isn't already on your list, you can actually develop your own using the Pulsar I/O SDK as well. Okay, so here, let me kind of talk about quickly DataStax, what our offering is. Basically, Astra, we have Astra Streaming is our managed Pulsar platform. It's easily, you can quickly go there, you get $25 credit per month, right? After 1 month, you're done. If you're doing proof of concept type of projects, it's perfect. And, personal projects, all of these things. And you can basically quickly set up your tenants right away, Pulsar Streaming. Astra Streaming is the managed Pulsar. And then there's also Luna Streaming if you want to develop, deploy your own. But then we also offer you some enterprise support too if you want, right? And then there's also open source if you kind of want to go all open source as well. And there's also a nice community Slack channel kind of support. And then again, Pulsar is the messaging substrate. So if you're kind of using Pulsar, use the Pulsar native messaging, or you can also, if you want to connect back with your Kafka system, we have Starlight or RabbitMQ. Again, there's also Starlight for RabbitMQ and also Starlight for JMS as well. And these are like just an example, quick, right, kind of showing you pictorially what is the very rich ecosystem of connectors and clients that we support over here. Okay, so I think I'm pretty much kind of up for the end now. So I just want to quickly share with you the appendix, the resources. These are, the open source, links for you to get to Pulsar, Bookkeeper, and Zookeeper. Then there's also Astra, which this is our managed cloud platform, Astra, and then also Astra Streaming, Luna Streaming that I talked to you about. The documentation link is here, and then there's also change data capture for the Astra platform too. So essentially, you have Cassandra source, but it can output data to different things such as Elasticsearch and other JDBC connected to some other database destination. And then there's also community resources of our Slack if you want to sign up for that, right? And also this different source code, DataStax on GitHub, all of these things are in here. So if you're interested in that. And then also, if you're interested, if you're, want to kind of try out more of our Astra DataStax, you can use this link and also use this code to kind of get additional credits too. But this one, it does require your email address. But if you sign up for just the free tier, we do not ask you, actually, I'm sorry, we do not ask you for credit card number, I should say, but it will need your email address so then we know how to communicate with you. Okay, and this one is 5 minutes about Pulsar on our YouTube channel for DataStax developers. And then also I have my own Twitch stream every Wednesday if I'm not traveling at 2 p.m. in US Central Time. And that's where I can kind of demo to you some of the usages of Apache Pulsar and the Astra streaming, the DataStax offering as well. And then if you want to get more information at DataStax, we have an awesome Astra kind of a self-paced kind of tutorial site to get more information too. And this one too, just want to share with you a benchmark report like Kafka versus Pulsar. This one is from Stream Native. They have done some benchmarking. And with that, I want to thank you very much for having sat through this talk. I hope it has been helpful. And I invite you to reach out to me on my, you can connect with me on LinkedIn, follow me there, connect, and I'll connect back with you. And then my Twitter handle, follow me there. Also, I have a Discord channel if you want to reach out and just share with me your story. You want to tell me more things, you want to kind of ask for advice, I'll be always there to answer your call. Okay, with that, thank you very much.